The following session will cover displacement map mathematics using render tree. First, let me explain the setup we have here. This is the surface we'll be using for displacement map. Currently, there's no displacement map being applied, as you can see here. As we make a render tree connection, the surface will displace. The outline here represents the actual displacement height that's going to be applied and rendered in the render region. So we have constrained the displacement map to go from positive to negative, which is 0 to -1. This height can be changed by going to geometry approximation under displacement tab and changing the max displace. Currently this is set to 1. So it means that the displacement map can either go 1 positive or 1 negative. Now let me show you the actual gradient shaders that we use for this displacement. Currently, as you can see, this creates a vertical gradient going from black to white. If we connect this shader to the displacement map, a value of 0 means it's not going to push the surface. It's going to leave the surface at 0. As the actual surface moves and basically gets into brighter displacement map, it's going to push the actual surface by 1 soft image unit. So a color of 1 means it's going to push the surface by 1. If I connect the displacement map gradient, as you can see here, black will leave the surface at 0 as white will push it towards 1. What I have done here is, in order to represent better the displacement map from positive 1 to -1, I've created this very simple render tree that takes the actual intersection point as it renders, extract the y axis and put it in the gradient such that we can have a surface that is colored depending on the height of the displacement map. So this value here, whenever the surface reached the bottom of this cube, for example, will get a red color. As it moved towards the positive displacement map value, the actual color will go up the gradient space and reach this color. So right now we have some sort of bluish color right here, and it goes up the gradient space. So as you can see, it's using this particular value. During the demonstration, it's going to stay connected to the Phong shader for to be able to visualize the displacement map value. It does not affect the actual displacement map, so we will be focusing on this particular render tree using the material displacement port. Thank you. Using textures in images as displacement map is a good source of realistic displacement look or surface detail. One of the drawbacks of using an image is the actual displacement range. The actual pixel color will range from either black to full intensity white, but it will not contain any negative displacement, so -1 for example, or -0.5. If you, for example, you use an image that is 8-bit or 16-bit, they are bounded to have displacement map ranging from 0 to 1. If you're using a float image, the float image will allow to store negative value. In a case you're using an 8-bit or 16-bit image as a displacement map, it will be required for you to add few nodes to be able to position the actual displacement map such that the displacement goes inward the actual objects and not outward. So this is a quick glimpse at the render tree nodes you will need to be able to create a displacement map from an image.